Welcome to the On Now Digital's just brief webinar series on helping fluid testing laboratories. We have set this webinar up into 3 parts. Those parts are covering the gathering of the data, the analysis of the data and the information, then also the presentation of that information back to customers. And again, we thank you for coming. This section here is covering that first topic of how to properly set up your lab data for fast, accurate, and organized data collection. So we're really emphasizing the gathering of the information here up front. We know that there are ever increasing demands on all of our time, and that the goal is really that we're always looking for ways to improve, to speed up our accuracy and our quality. And so we're hosting these just as a means to try to help you accomplish that in your everyday work. So I'm Mark O'Brien. I'm the business manager. I'm just going to be facilitating here today. We also have as presenters and panelists, Mr. Brett Rose, manager of development and delivery, and Mr. Bill Hayes, our senior software engineer. These gentlemen have decades of experience in the industrial automation space, and more recently, in the last 10 years or so, they've really focused primarily on fluid testing laboratories. And so we're hoping that some of their expertise in working with these oil and fluid testing laboratories, we have some knowledge and expertise that can be a resource for you. And with that being said, we're going to jump right in to our topics today. So today's menu, again, these are snack size webinars. Hopefully these are break size, 20 minutes, 30 minutes. Quick housekeeping note: we're going to try to keep it about 20 minutes with 5 or 10 minutes at the end for any questions or comments that we have. If you have any questions, I'd encourage you all to use the raise hand feature or the question box over there, hopefully on your control panel on the right. And if we don't answer them through the course of the webinar, we will take some time at the end and go back through those questions, make sure that everyone gets their questions addressed. So here we are. Today we're going to talk about some data collection tips. Where does good data collection start? Interfacing with instruments and with your LIMS system or your databases. We're going to talk about, does that data meet your business requirements? And then we're also going to just talk briefly on, hey, what are the results of implementing some of these systems? So here I'm going to ask Bill to kick off our conversation here and just say, hey, Bill, set the table for our conversation and say, hey, where does efficient and accurate data start?
Great question, Mark. You know, when we talk about laboratory and data analysis and data acquisition, really this begins in the field. And the question is, how efficiently, how accurately can we gather that data? We want to be only touching that data once. If we're retyping or hand entering data that's entered on clipboards and such in the field, that's a problem. We should be leveraging mobile technologies. We should be able to provide things like, oh, this fellow here, he's collecting machine cycles or operational hours or whatever. He needs a place to be able to enter that would be verified, so we know that his data is correct. We want to be able to catch any typos. It says, oh, you know, operation hours should only go up, they shouldn't go down. So this is a great place to shield our input data so that it's really accurate and it's presented to the system very accurately.
I think you're right on there, Bill. Kind of in conjunction with that, out in the field, the next step when we talk about data collection is really that registration process. So after that sample actually shows up in the lab, do you have any tips or just ideas on what we need to do once that sample hits the lab to be able to register it properly so it flows through the rest of the process in an appropriate manner?
Yeah, so we're talking about, of course, container identification, and if we're using barcodes or RFID tags or whatever that technique would be. And then we're also talking about, handling those exceptions as tracing things through the mail, as well as loss and broken containers and the other things. How do we handle those so that we can communicate this information back to the customers? And then just all the integrations that can happen in that is we're talking about order changes, order processing. It's quite an can be quite complex depending on really what the customer's needs are, and really that's where it's at. Where we're trying to say, what can we do to provide the best data to our customers accurately, and really using those systems to give us a competitive advantage.
Yeah, I want to touch on this really quick too. As far as where the data begins, Bill is absolutely right. It begins out in the field. And it's more than just what you're looking at or what your business does. So for example, if you're a laboratory that does sampling and testing of transformer oil, there's going to be additional data points that you need to look at and you need to maintain and collect in the same efficient way that you do the sample information. That's extracurricular data points, which could be weather or whatever else you can find. It's always good to try to find as much data as possible so that you can increase or enhance your analysis in the future moving forward. And additionally, just to reiterate what Bill had said, having a solid foundation of that data available is going to make the rest of the process go much more smoother. And then if you can keep that data in your system and reuse it for future analysis and or to help with future data collection, such as maybe equipment information, and keep that stored and associated with your samples, it's going to be much easier for you in the future.
That's a great point, Brett. Thanks for touching on that. I think you guys are hitting the nail on the head when it comes to those upfront data collection tips, both in the field and with the registration process. So I'm going to move just very quickly to that next step in the process, which is, okay, so the sample has been pulled out in the field. You've collected all the appropriate data, hopefully using some type of technology, so that you don't have to rekey or re-enter data twice. You've registered the data in the lab, so you know that the samples are there. Now it's time to route those samples through your lab and actually starts coming in contact with your instruments. So Brett, maybe you can start answering this question, but how do I know, or what's the best practice for collecting that data off of the instrument itself, and how do we know if that's even possible or feasible?
Sure, that's a great question. And automatic data collection is where you want to head. The less, as Bill had mentioned, the less you have to touch the data, rekey it, review it, the better. So you want to endeavor to get that information flowing through your systems as autonomously as possible. So how do you know if your equipment can even do that? Well, you have to understand your equipment. I mean, you're in the business of laboratory test results, and it's more than just the data you're looking at, but you need to know your equipment. It reminds me of an example. I was in the Navy, and all the captains of the ships knew every little detail of the ship they were on, everything from the weapon systems that the ship might have, all the way down to the capacity of the oven and how that worked. So they knew it to a T. So as far as understanding the automatic data collection for your equipment, learn about it. Learn about it as much as possible. Find those manuals, dig them out, brush the dust off them, read beyond just seeing where the test values are and see what it's capable of. Some of your equipment will have the capability to interface with other downstream processes, and most likely one of two ways. Some of them have a computer to a computer interface, so the equipment might be connected up to a running PC machine. When the data arrives in there, it might have the ability to use something like an API or application interface to then send the data to another location to continue the processing. Another capability which I've seen a lot is the machine to file interface. So a machine will do the testing of the samples, and then it will generate a file in a CSV or some sort of custom format to be placed in a file folder somewhere that then can be picked up by a custom process you have or might need to build that will interface with the rest of your downstream processes and systems, such as your LIMS system in which you continue the process forward. Some of them will not have easy connections, or they might have proprietary connections to do so. So some equipment doesn't play well with others. There might be a vendor that has a machine and they expect you to interface with XYZ product. So there might be a few ways around that. There might not be, but it helps to reach out to the manufacturer of the equipment and see what your options are. And feel free to go beyond the manual. Ask for help, reach out to people, reach out to other laboratories that might have similar equipment and say, hey, I need to make this more autonomous. What can I do here? And hopefully that'll help you moving forward.
That's awesome, Brett. Thanks for the insight on that topic. Bill, is there anything that you would add or contribute to what Brett was talking about?
Well, he covered a lot of areas where we're talking about networking devices, where things have a PC interface or have some connectivity. If that's really more primitive, it's a serial or USB, that can also be sometimes software controlled. We've done that kind of work before. I've done that kind of work, and really kind of bypass systems where they're, again, entering data manually because there is no interface to it. So it is sometimes possible to retrofit more antiquated equipment. Sometimes it's possible to add transducers and really bring automation to a device that doesn't have it natively. And lastly, of course, there's some things that are, just manual qualitative, and there's not much you can do about those. However, you can make that data entry as simple and as efficient as possible to, again, reduce typos and, make that process faster, more accurate.
That's awesome. Perfect. Thanks, guys. Well, that you guys both touched on how that data entry process with a lab information management system or a LIMS. Many folks, I'm sure, are aware with that, or in general, just a database that's going to house that information and store it and keep record of it so that you can report on it downstream. So, Bill, I know you've worked with these types of systems pretty intricately in the past. You want to talk just very briefly on the key items of setting up a LIMS system or a database, just to make sure that it meets your organizational requirements?
Sure, Mark. And yeah, you're saying am I a detail guy on some of this? Yes, I am. Where, when you're talking about a laboratory system, it's really key to select the right product and scale that right for your business and for your business growth and your expectations, because that, a lot of times a vendor will push their LIMS because you've bought their instrument. That's not always the best choice. Really, it's all about, again, ROI, cost and accuracy, and what is your traceability requirements, and really questions about, are you able to handle growth? And then the next part is, what is your business model? What are you trying to accomplish? What is your customer facing needs? And so you can start to gauge what is a real ROI. I always suggest picking systems that have a high level of extensibility, You need to be ISO 17025 compliant. There's a lot of other access controls, security. It's all about picking a product and a solution that's right size for your organization.
Yeah, and I want to touch on that as well too, if I may. Yeah, it's just as Bill had commented, don't overlook the details. I mean, laboratory and testing, it must be detail oriented. So it's, I know the old saying that ignorance is bliss, but you definitely don't want to do that in this industry, because you want your data to be accurate. I mean, as far as I see LIMS systems, there's two major concepts you want to take an approach towards, and that's scalability and abstractions. So what does that mean? Scalability, it means you can continue to grow your business, handle more tests, and abstractions gives you the capability to potentially pivot into other industries or adapt to your own changing industries. So you want to make sure you have those things covered, and that extensibility that Bill had mentioned, that will help you succeed better as a business.
That's perfect. Really good insights, gentlemen. Thanks for those. So we're going to move right on to just our last, just talking about the results very quickly. And again, we'll just have to do this briefly for the sake of time. But what are some of the results that we've seen? Bill, I don't know if you want to touch on this. What are the types of ROI? You mentioned ROI a couple times. What are the types of results that we've seen? How have we seen this help other people? You know, does it work? Does it actually help me accomplish my goals?
Yeah, it works when you say you're setting really a foundation for continuous improvement. So you deploy a LIMS, you end up where you say, oh, you've got some training to do on your staff, and your processes are going to change, and that can affect negatively processes for a short while. But really the goal is to give you a long-term sustainable continuous improvement model. And that's really the foundation that you're looking to set, because there's some tactical, there'll be some immediate things to resolve, but really that's the process to say, I want a way where I can continue to do this. How do I improve my accessibility? And really, how do I grow the system, adding new methods? How do I add new staff? How do I improve my training model? All those things are affected by deployment.
Yeah, and I'll touch on this as well. Every time we've been into some of these systems and looked for ways to improve them, there's almost always something that we find, because you want to head towards faster, more accurate, and cheaper test results to help you pull ahead of the pack in your industry. And one of those things is to consider more automation in as much places as you can throughout the entire process. Less personnel doing the menial, potential error-prone work is going to help you out a lot more. Having easier capabilities to take on more work to help ensure your growth is a huge benefit, and something you should strive towards with the abstractions and the automations. And then as far as an example, I can think of one off the top of my head. We had a 10-fold increase in efficiency and scalability on one of the lab processes that we've helped improve on with one of our clients, which saved them a very large sum of money, and it got the data to their customers much faster, making them very happy about the results.
Yeah, that is definitely kind of the double-sided the benefits that I know we've seen a handful of times. Is one, it increases the efficiency and decrease some of the costs, and then two, that just increasing the customer experience just in general, getting their data faster, more accurate, and cleaner. So thanks for those explanations, gentlemen. Extremely helpful. Some takeaways here just before we leave. Again, thanks so much again to Brett and Bill for jumping on and leveraging some of their expertise for us. The takeaways for today, again, on our session, just talking about gathering the proper data. It starts in the field. Hopefully after it starts in the field, you can register that information and you can interface and interact with your instruments appropriately and connect that with your LIMS system. 3, that's going to enable simple, structured reporting for the future. We're actually going to touch on that in sessions 2 and 3 of the webinar series. How do you analyze that data that now you've collected, and then how do you report it back to customers? And again, all those things hopefully equaling some cost savings and really stability and scalability of your systems, as Brett and Bill both mentioned. Just laying these types of systems, laying the foundation for your business to be able to grow and scale and really accomplish the types of growth that I know that we're all shooting for. We really appreciate you guys joining us here today. Thank you so much for coming. Brett and Bill, thank you again for your insight and your knowledge, and we look forward to talking next time.
And my pleasure. Thank you, everyone.
Thank you.
Today, we are going to be talking about the analytics side of your laboratory data. So in session 1, we covered how to properly gather information, both information from the field and then also information from the instruments and equipment itself, and how to properly store that information for consumption. Now we're going to talk about the second step of the process, which is really the analysis step. So what are the best ways to look at this information? What are some common techniques that they use so that you can have better insight for your customers, and then also for yourself and your own business operation? So with that being said, we're going to jump right in here. I am Mark O'Brien, the business manager here at On Now Digital. I have joining me as panelists today, Mr. Brett Rose, our manager of development and delivery, and Mr. Bill Hayes, our senior software engineer. You gentlemen want to say hello, introduce yourselves?
Yeah, absolutely. I'm Brett Rose. I'm the manager of development and delivery with On Now Digital. I've been with On Now Digital since its inception, and had a good time working here. I hope you learn a lot from today's seminar.
Well, this is Bill Hayes, and I'm the senior software engineer. And I've been with On Now Digital since its inception. And yeah, we're excited to have you to share some of our knowledge and background, and hopefully you'll get something out of today's meeting.
Excellent. So just some quick housekeeping items before we jump right in here is if you have any questions or comments as we go, feel free to use the raise hand function or the question text box. Go ahead and type in your question. We'll handle those throughout if you have any, or we'll hopefully leave a couple minutes at the end to discuss any of those. We're trying to keep these to snack size, so enough to happen over a break or a lunch break. So we're going to try to keep it about 20 minutes with about 5-10 minutes for questions afterwards. And again, we have a couple of resources too as well on the webinar. So we have some a white paper and also an ebook that you can download. So if you want those handouts, feel free to download those as well. So what's on today's menu? Today we are going to talk about understanding data classification versus analysis. We're also going to talk about, hey, how do we know what analysis types we're supposed to use? And then third, what types of diagnostic systems are actually out there? What are people using today, and what are some options for our system? We're going to dive right in here. Step 1, we are going to start our conversation off by, Mr. Rose, maybe you can tackle this for us first, is what is data classification? How does that relate to the levels of data analysis?
That's a good question, Mark. We definitely see the words classification, analysis, and even diagnostics, and how does this all fit together, and what is it? So let's start with the data classification level. Data classification, in my mind, is a way of looking at the individual data points that you have within a given test set. So for example, if you have test that took place on a given date and it contains 10 data points, you'd look at those 10 data points individually and apply a classification to them. This classification could, in a way, is its own sort of type of analysis just on that individual data point. But what you're looking to do is apply a conditional state to that data point, letting you know whether it's in a good condition. Maybe it's not necessarily in a good condition, but it's not bad, so it's in sort of a caution state. And then you have the bad state. Hey, this data point came in, and based upon our levels of analysis for these classifications, it's bad. So you might mark it as such. So yeah, in a way, it's a type of analysis. The classification is use the analysis to get to that level, but to apply to that individual data point. Once you have those classifications of the data points, you're going to want to take it further through more stages. So just looking at one individual data point and its conditional state, and in our situations, we typically use the red, amber, green methodology to apply a classification to a data point. But once you start looking at all the data points together, you're in your first stage of analysis. And that means maybe you have a data point that was classified as bad, and then another sort of related data point was classified as good. Once you look at those together as a whole, you might say, hey, the one that's classified as bad, we don't care so much about that. So we're going to say this stage, everything's okay. Or you might say that one data point in conjunction with the other one being good puts you in a different state that you need to look at. Once you look at those together, you take it then to the next level and you look at the environment of the data points or the test result, the context of it. So what is this associated with? What's the equipment and its parameters? You might even look at what the weather was that day, and then further your analysis to say, well, if this is bad when it's -50 outside because you're in Antarctica or whatever, it might mean something different. So you just want to build on those as the levels go by. And what's your end goal is trying to get to those questions that you have, such as how do I determine my maintenance plan? How do I assess the risk of production in my industrial environment, or determine where to spend an influx of money? So you just build those stages one on top of each other to get you to that point. So you might have the analysis on the equipment as a whole after you've moved through those first two stages, and then you compare it against your entire fleet of equipment that might have had testing done on that day, and determine what your fleet conditional state is to answer those questions I previously mentioned.
That's awesome. Bill, do you have anything to add or any examples on that topic?
Brett mentioned context, and really what we're trying to do is when he went through the individual point classification. We talk about context. Quick example is heart rate. So if I was to check my heart rate after a jog and it was 140 and I was in the aerobic zone, that'd be great. However, if I was laying in bed taking a nap and I woke up with a heart rate of 140, I probably want to go to the doctor. It's all about that context so that you can really understand the entire scope of the data. And really, in this environment, we've been talking about in our previous presentation about mobile data collection, environmental collection, as well as historical data analytics, and really putting all that information together to come up with what is a business decision process, and really a systems related comparison, where we're even talking about maybe even multiple pieces of equipment that we're testing, or something where we're looking for interactions between those things. So yeah, it's all about coming up with a context to understand the data.
Yeah, absolutely, Bill. That's a good point, bringing the heart rate into there. And that might be stage 2 of your analysis, where stage 3 or 4 might be looking at the whole family and what is their typical wake up heart rate. And you could use those decisions to define what next steps you might have.
That's excellent. That's excellent, gentlemen. Thanks for touching on those. And that example, I think, really is really helps define what we mean when we say analysis. So again, we're going to jump to step 2 here. Now, okay, we have the data. Now let's talk a little bit about, hey, how do I know what type of analysis to use to get me the right classifications on that data? We have 6 items listed here. Brett, do you want to take some time and just walk through which these are algorithms or rule sets that you might use to understand and classify and analyze the data that you're looking at?
Yeah, absolutely. So yeah, there's plenty of ways that you can look at the data, and that's how you get to that initial classification or another stage of classification to get to your end result or to answer those questions. And some of it's determined upon standards that are set out by, let's just say IEEE or ANSI or NFPA of how things should be analyzed to determine it's a good condition, or there might be custom setups. But just to describe some of these, if we look at nominal values, we might say hydrogen, for example, in testing oil might be bad at a certain parts per million count on the test results. So you'd look at a linear regression of that data, and you would say maybe 3 parts per million is in a warning state, but then you get to potentially 6 parts per million and something's bad. So they're just kind of thresholds or rungs on the ladder, depending on where you're at, to determine the classification of the data. Rate of change gets a little more complex, and this is where you're looking at not just the individual data point, but maybe some previous data points behind it to determine, are you in an exponential curve of increasing your value or decreasing your value of the data, or is it just a linear path, and that's okay because that's what's expected. So you're looking to set parameters based upon those rates of change to determine what's good or bad. Percentage change might just be you expect it to be at a certain value, such as maybe 10, and you're going to say that maybe 2% deviation plus or minus of this is okay, but 5% might be bad. So you're going to classify that in that sort of manner. Standard deviation is where you have a group of data points and you expect stuff to potentially be, or those data values to potentially be in within the 0 standard deviation or within the top of the bell curve. But you might have a classification that says, hey, if I'm 1 or 2 deviations plus or minus, and you can look at either way if you want, then something might be considered caution or bad. And then we get into the fun ones, the ML, otherwise known as what you build artificial intelligence out of. And this is where you don't have an exact algorithm to determine the classification of the data. So you need to take other approaches towards it. And this is where you can get a lot more complex if you need to, and potentially look at other data points to come up with a classification of that one data point you're looking at. Supervised machine learning is where you have a data set and you already know the classifications behind it. You might not know exactly how those classifications arrived. So you train a machine or a computer on that to understand how it's supposed to classify the data based upon that training data set. Then you're able to take that out, and I like to call it a machine brain, and apply it in real world examples that will use what it learned from that training data set to then apply those caution or alarm values of the data point you're looking at, or set of data points you're looking at. And unsupervised machine learning is just that. You're not supervising it while it's learning. You're essentially providing it data and saying, hey computer, I don't even know what I don't know. Can you come up with some sort of classification of the data that might help me understand the data set I'm looking at better to make those further determinations on what's good or bad. So that's a little bit different technique, and sometimes you use unsupervised learning to get you to that supervised point and walk through in stages to improve your classification. So basically, if you have an algorithm and you know it works, use that. If you don't exactly know how to get to that endpoint you're getting to, you might use something like machine learning. And an example of that would be facial recognition to describe how a person is feeling. I couldn't even begin to think of a formula to come up with that answer. So what you do is you start to interview people with their facial expressions, and then you run through that as a supervised machine learning. And then the computer begins to understand what expressions it sees in a face that determines how a person is feeling.
That's excellent, Brett. Thanks for walking us through, especially those two last ones. I know are hot topics. A lot of people are talking about, how they use the ML for AI, and especially as it relates to the IoT space and just the overall overwhelming amount of data that we have to sift through. Some of those tools can be really advantageous, but some of the simpler ones too. In most laboratories, I know that those rule sets are really very widely used and can serve as excellent tools regardless. I'm going to jump right into, just for the sake of time, because I want to make sure that it's on time. Okay, so we now have established, hey, we're going to use this specific, we're going to use, percent change is the best rule of thumb for this specific test or this group of tests, or we're going to use some supervised machine learning to classify this data. Either one of you can jump in on this question or topic, but what do other laboratories use today? What are tools that other folks are using, and what are the types of we'll touch more on this in session 3 as far as communicating that back to the customer, but really talk about the tools that labs are using to accomplish applying these algorithms and rule sets.
I'll take that one, Mark. So really, we're talking about situations where companies have developed maybe internal code where they analyze data and they try to come up with their their diagnostics, and that can take the form of really custom programming. Often it takes the form of spreadsheets, and those can be a little unwieldy and manual, depends on the technical abilities of the laboratory themselves. Usually that code is tailored to a very specific type of process. Often though, we're really talking about information that an expert within the organization will use, someone who's really an inside employee with the knowledge base, understanding of that. And what we've done in the past is to really capture that key analysis and then come up with algorithms or try to turn those into real algorithms.
Yeah, good point, Bill. There's some of these organizations that we've worked with before have had people in their environment that provides that analysis, but they don't quite have it formalized down, and no one really knows. Let's just use Jimmy Dean, for example. Jimmy Dean's been with the company for 30 years. He's providing the analysis, but no one really knows exactly how he comes up with that information. Artificial intelligence might be able to step in here in this situation because you have the previous analysis that was supplied based upon the data inputs that were available and the classifications or analysis results of that you could apply machine learning in that example to sort of come back and reverse engineer what your employee Jimmy Dean was working on and how he did so.
That's perfect. I think you guys are right on with the approach and how laboratories are handling that. Again, there's a variety of different systems. I'm sure that folks are using. We're familiar with a handful. So here, just very quickly, again, we can touch on these briefly. Talk just briefly about some of the results that we've seen of companies that have used these type of systems. I don't know if Bill, you want to walk through some of these? You guys want to tag team?
Well, I'll start off with really, when we ask, does it work and what are the benefits? The key benefit, and this is where the improvement in the customer experience is that result repeatable? And as you approach automation and as you approach data collection, data analysis in an automated fashion, it's efficient to do and it's very repeatable, and that makes customers happy.
Yeah, I can speak to the improved efficiency. I mean, the faster you can get the data in and out of your system and into the hands of the customer, the better they're going to like working with you, because they're going to have that trust that when they supply you with the information, that you get it right back to them as soon as possible. And then being able to do this in a cheaper fashion, so less manual involvement with moving data around or staring at data points to come up with a classification. If you're able to automate that, you can do it cheaper and run much more results through to get that in the hands of your customer faster. And you really just want to touch the data less and make sure the data keeps moving through the system as fast as possible, and get the personnel you have on staff doing a lot more value-added tasks instead of the menial ones that could potentially be automated. And what this will do, it'll help give you more scalability opportunities to potentially pivot into other industries, as I mentioned with the last seminar topic, and be able to provide more lab results than you might be doing right now. And let's face it, efficiency, it can make or break a company.
Right on, Brett. Really appreciate you guys covering those topics. So here, just very quickly, I'm going to summarize. Again, three things we covered today, 3 takeaways. Hey, how do we turn this data into actual information? How do we use the right algorithm to classify that information? And then what types of systems are we using spreadsheets? Are we using something internally that we've built? Are we using an outside tool or product that helps us classify and analyze that data? What are talking about the different ways that we can use that data? All of that goes into, again, what our third session is going to be, which has to do with presenting that information. Now that you've gathered it all, now that we've analyzed it appropriately and classified and hopefully gleaned some insight out of it, how do we present that in a way back to the customer where it makes sense for consumption? They have actual information that they can walk through. So with that being said, we're going to open it up to any questions. Again, don't be shy. It looks like we did have a question that came through here during the session, especially there was a little bit of interest around the ML and the AI topics. And again, this might take us down a little bit of a rabbit hole because there's so much to know in that industry. But the question came in, do you have a practical example of using AI for business? Do we want to maybe, Bill, do you want to maybe see if we could tackle that, a practical example?
Sure, I can take one of those. So not very long ago, I was working on a project where the question was really logistics related. And our company client was, they're selling windshield wiper blades through large retailers, and they kept running out of stock in some markets and not in others. They're running out of stock bad in a way that they would actually miss sales. And so we got involved with that and applied a neural network, an artificial intelligence system to look at that information and to look at weather information as well to see how the weather was being affected there. Interestingly enough, the algorithm eventually came up with a predictive model that did not use the rain as a predictor, but the lack of rain. And so not something that we would have immediately thought of, but as it turns out, practically there's a consumption of a product, even if it's just aging. And so, and that was the outlier that the predictive model came up with. And it was very, very effective. That turned into a system that would essentially ship product to locations before they ran out of stock based on weather predictions. And that really increased their sales throughput and made them a lot of money. So that was, again, the business element for a artificial intelligence algorithm.
That's an awesome example, Bill, about just a real life application. Brett, I know you touched on one, just the facial recognition, some facial recognition items kind of through the talk. Is there anything else that you might want to add, or any other examples that you want
to? Oh yeah, absolutely. I mean, we're all familiar with the self-driving cars. Those aren't set up with algorithms in place, but just algorithms. It's a lot of machine learning that went into those on the plethora of sensors that are on those vehicles that allow that to stay between the lines, to see a human in front of the vehicle and know to hit the brakes. And we've seen some downsides to that too. So you have to be careful to make sure that your machine learning is trained and making sure it's adapting to any environmental condition that might show up. But yeah, that's probably one of the biggest examples in the industry. That's probably one of the most successful as well.
You guys are right on. Those are fantastic examples. Thank you for diving in on each one of those. So again, thank you so much for joining us today. We really appreciate you guys being here. We hope you learned something. Again, if you have other questions and comments, feel free to send them our way. Shoot us an email. We'll be more than happy to get back to you or set up a time to talk. Brett and Bill, thank you so much for joining me and sharing some of your expertise. We look forward to doing it again here shortly.
Yeah, my pleasure. Thank you, everyone.
Thank you, Mark. Thank you, everyone.
This is the third of 3 sessions where we've talked about, number one, how to properly gather laboratory data, field inspection data. In the second webinar, we covered how to analyze some data analytics techniques and how to properly look and categorize that data. And now here today, we're talking about how to properly display that data back to your customers so they can receive some actionable insights. So again, we're going to try to keep this short. We're going to try to keep it just about the 20 minutes with a few minutes for questions at the end. Again, we just want to be cognizant of everyone's time, and again, just enough that you could take over a break or a short lunch or the like to be able to dive into some of this content. So again, I'm Mark O'Brien. I'm the business manager here at On Now Digital, and we have joining us today as our panelists, Mr. Brett Rose, our manager of development and delivery, and Mr. Bill Hayes, our senior software engineer. You gentlemen just want to introduce yourselves really quickly for those of you that don't know.
Yeah, hi, this is Brett Rose, the manager of development and delivery. I've been with On Now Digital since its start, and as usual, I hope you guys are able to take away some information from our webinar. And Bill Hayes is our senior superstar software engineer.
Hello, and yes, I am the senior superstar engineer, and welcome to our presentation.
Excellent. Thanks, gentlemen. Well, with that being said, here, let's take a quick look at what we'll be covering today. We're going to be talking about the benefits of a customer portal and specifically self-service. Then we're going to talk about some reporting details. We're also going to talk about some hosting and security to-dos. And then lastly, we'll talk about, hey, what are the results of that? What are kind of some of the savings and some of the systems and customer improvements that we've seen as a result of implementing some of these systems. So I'll kick us right off today and we'll say, okay, can we take a quick step back and just define what is this thing as what is this thing that we call a customer portal, and specifically for a laboratory, how does that look? Brett, do you want to kick off our conversation?
Yeah, absolutely. Yeah, you think portals, that's something sci-fi or what are we talking about here? Maybe you've seen those Avengers movie where there's a character called Doctor Strange that opens up a portal and everyone on the other side gets to see what's in there and see what's going on and potentially go through it and interact with it. That's similar to how a portal is for a company to provide to their customers. They open that up and make data available, real-time, dynamic, to the customer that allows them to view it anytime they want. Typically, this is all digital. Use some sort of web-based environment that this runs in, so end user can access it from anywhere, and it could be hosted on site at your location, or you could potentially use cloud hosting for it. And a lot of what you do is you centralize the data that a customer needs in one area so that they always have access to it. So it's a lot different from those reports that you maybe printed off and mailed to the customer that they filed away in a storage cabinet somewhere. In this case, with the portal, all of that is available for the customer to look at whenever they need to, and in an interactive way. So they're not explicitly tied to that one formatted report that you've mailed out to the customer. They're able to view the information in different ways they want to see it from different pages, and it's all live information and up to date as much as possible. The customers have access to their own information whenever they want, how they want it. They don't have to wait for you as a company to provide that data out to them. They can just get in there at 2 a.m. in the morning if they need to review some historical data relating to an equipment that just failed, without having to wake up one of your customer service agents in bed, or even requiring a customer service staff that's operating at those times. Some of the cool things you can do with the portal too is you've seen some of the postal service trackers where it lets you know when the package was shipped, where it is along the process, so you can provide better insight of the customer's sample data going through your entire process. So they have a good idea of when that is going to become immediately available within their portal. And then there's other tools you can do, such as graphing, allowing customers to analyze their own data so they can pick one data point that they might want to review, and they can look at its current data value and then maybe through the 10 years past to see what's going on. So it's a lot more interactive than just the printed version. That's what I believe to be a customer portal.
That's fantastic, Brett. Mr. Bill Hayes, do you have anything to add? Any examples that you want just to shed light on this topic before we move on?
Sure. Brett mentioned, we're talking that some companies are using email that send out reports. Those reports are generally static. They have email attachments, whether they're PDFs or just HTML emails. The portal gives the customer ability to perform drill down diagnostics and analytics. They can do custom reporting if they need to, that's custom charting, and really perform what if analytics. And that's key, because a lot of customers, they're trying to diagnose specific issues or make decisions about assets or whatever else they're working with, and them to be able to self-manage that is important. And then of course it's timely. Customers are all over the world. They have their own time zones. A portal helps mitigate that very well.
Well, you gentlemen are exactly right on. I think you're already starting to cover some of the jumping into some of the benefits of a customer portal, and especially as it relates to self-service. Bill, you just touched on it. Brett, you mentioned it as well. Can you tell us how a customer portal helps customers access information themselves, and also what are the benefits for your business as well? I know we touched on this briefly, but if we just want to dive into details.
Yeah, definitely. Yeah, there's two facets of self-service, like we have here on the slide. It's the customer and you as the business, and how does that benefit you? So self-service, let's take a step back and see what that looks like. It's the year 2020 now. People are used to doing stuff on their own, at their own pace, whenever they want to do so. Stuff like banking. We do banking online now. We don't have to make sure that we get off work a little bit early because we need to run to the bank before it closes, we can go home, take care of our family, eat some dinner, and then hop on to the bank's website and take care of stuff. So we don't need a customer service agent to deal with the customer interactions. The customer can go ahead and take care of it themselves in their own context that they're looking at. They can use their own processes to look at the information too. So like I mentioned before, with the mailing a report and having to wait for that, they don't have to do that anymore. Maybe they have a certain way that they like to go in and review the new data that arrives on whatever they want to look at, and they like to do these filters, these other things as they go through to analyze the data, and they can do that at their own pace, their own time, and in any way they want. And it's fast. It's faster for the customer, and that's one of the things that in this day and age, everyone wants everything as fast as possible. So, providing that self-service capability allows them to hop in there as soon as possible. And let's face it, it's the year 2020. Everyone is used to being able to access data whenever they want with their cell phones, with their computers, at their own pace. So you want to make sure that you keep up with the rest of the industry and how they operate. And some of the research we did on digital, we're showing that 4 out of 5 people expect that digital interaction to be available to them in order to see their data. So you want to make sure that you make the customer happy. Let's talk on the business side of things. So you can reduce customer service. You no longer have to worry about that ratio of maybe I have 1 customer service agent to 100 customers. With the self-service capability, that can look a lot different, and you don't have to be as concerned about that. It offers you ability to scale a lot better. So if your business grows, you don't have to try to hurry up and find more customer service agents. The customer is already expecting to do some of this stuff on their own. So you don't have to increase that ratio a lot more. And then happier customers grows your business, right? So as long as you make that side of the equation happy, your business is going to begin to succeed as well. And then even move into different sales methodologies, such as allowing that customer when they're looking at their test data to say, oh, I'm going to go ahead and schedule my next test and order through you, and that reduces unnecessary sales interactions throughout whatever process you have going on with your company, and just allows you to become more financially profitable.
Brett, I think you touched on those extremely well. Mr. Bill Hayes, again, any examples that we want to add to some of Brett's explanation?
Yeah, so when we talk about, of course, this self-service, we also talk about maintaining their own data. And often I think about that in terms of like equipment types or asset types. Let's take an example, my personal car versus a delivery truck. And those are 2 very different things. And when we change the type of equipment, we would expect the analysis behind that to be changed. Let's say they were looking at the car tires, and the tires have 3,000 miles of tread. If that's my car, that's not a problem. If that's my delivery truck, that's a tires next week. And so the status of that could change based on their ability to maintain their own data, and basically the diagnostics would change as well. So that can be very valuable for the customers.
You guys are hitting these right on. Let's jump into the next, again, Bill, as it relates to making sense of some of that data and contextualizing it. Brett, do we want to talk just, again, briefly on some best practices for data visualization, data presentation when it comes to displaying all these numbers and graphs and charts so that customers can understand actually what they're looking at?
Yeah, definitely. Let's take a step back and look at a report. So we're actually talking about portals here. Where does reporting even come into that? Well, portal is essentially a dynamic version of the report. So as we were referring to before, the classic PDFs that you were sending to people, or filling out a form by hand and mailing it, that's a static report. Those reports, they never change. They're always in that given format, and there's no interaction with it outside of just viewing what's in there. When we talk about portals, we go into more of a dynamic aspect of how the customer sees the information. So it's not just what was printed on that one date and sent out. It's potentially data that changes. It's historical data. It's being able to customize and what you're looking at in reports, such as filtering out by specific parameters, or sorting the data by another parameter to best adapt to what the customer needs to look at. And then you have the dynamic plus static, which is the customer's already sort of configured how they want their data to look, and at that point in time, they might create a static version of it to, for example, walk over to their boss's office and say, here's what we're looking at in relationship to some maintenance or further actions that we need to take on this data. So you can combine those, both the static and static and dynamic methodologies, into a portal just to provide a better user experience behind that. And some of the best practices for data presentation is you want everything to be clear and concise. So for example, you might have went to a doctor to get a blood test, and you got the report back, and there's some things that are colored in certain ways, and it's all jumbled together, and half the time you don't really know what any of this stuff means. You don't want to do that. You want to make sure that when a customer is viewing the data, they know exactly what's going on with whatever's being tested, so that they can make further decisions on it, instead of having to reach out to you as a company and say, yeah, I see these data points, I see these colors here, but what does it all mean? What am I supposed to do with this? So you want to eliminate that need for them to go back and ask further questions, and then make sure there's plenty of white space and separation between different contexts of the data within the report, so the customer is not having to do a lot of mental gymnastics to look at that data and determine what they want to do with it next. So a lot of stuff, a lot of that goes into making a good report, and that in and of itself is also an industry in making sure it's done right.
Yeah, definitely, Brendan. When we can talk in depth, maybe at a future time, about UI and UX and data visualization. That might be its own webinar session altogether. Bill, do you want to touch on just briefly? Hey, now that Brett covered some tips on presenting that data, do we want to touch about, hey, what now can the business learn from the utilization of the site and of the portal?
Yeah, so we're talking about reports, and really this is the process of for the developers and for the people that as yourselves, how do you own a portal? And really the question becomes then, well, how are our users, our customers, interacting with the data that they have on the portal, and help direct where we're going to focus our web dollars and for improvements and reporting improvements, understanding what reports are important to the customer. And then, it's often how often are they reviewing the reports, but is there anything, for example, that you've built into the portal that the customers are not using? There could be features, analytics, and other information that would be useful to them that they are unaware of, and that's perhaps because of a presentation or just explanation of how to use what can be a very technical site in some cases. So all those things are things you'll get from the usage and statistics information.
Yeah, Bill, I definitely think that's a critical point. when you think about, yeah, how we can use, usage data to really make better improvements on the site, or better products or better reports. It really just helps close that feedback loop. I think that's incredibly valuable. Next, we're going to talk just briefly about some hosting and security musts. Brett, do you want to talk just briefly about, hey, what are some best practices for security? Where should I host this platform if it's something that I'm looking to do?
Sure. Yeah, absolutely. I mean, you made the right choice. You're going to make a customer portal, and you hear about the cloud, and you have an IT department that has all the equipment. How do you decide on what to do between the two? And cloud hosting is essentially it's equipment that you don't have to maintain, you don't have to keep updated. It's a service to you to be able to use those resources in whatever way you need to do so, such as hosting a customer portal. But what do you need to look at between the two to determine what the best decision is? Well, what is the type of data? Is it sensitive data, or data that might have legal risk attached to it? There's a lot of steps that you're going to have to make sure that you take in order to make sure that that data is secured. Do you have the proper equipment on site with concerns such as HIPAA in place, and accounted for, or being able to process credit cards, or do you have to purchase more security gear to take care of that? Maybe you do, maybe you don't, maybe you don't have it, and you start looking at cloud hosting, and in my mind, those services that are provided for cloud hosting, as long as you choose the right ones, that's what they do for a living. They take care of a lot of that for you and keep everything updated and keep it secure. But sometimes it can get expensive, so you want to make sure that you balance the pros and cons between the risks and the costs between the two. But one of my favorites with cloud hosting is if you have a huge influx in business for your company, you don't have to hurry up and scramble and buy more equipment resources and install them to be able to accommodate that new business that's coming in your way. In cloud hosting, you can just hop in and move a slider across and increase resources for that. So there's a lot of stuff to consider, but as far as pros and cons of cloud hosting and security, I know we're running low on time here, but let me touch on that really quick. Make sure you always have firewalls in place, virus scanning definitions, logging always needs to be there, and encrypt everything as much as possible in reference to data, to networks and access, and then make sure you understand what the different roles of the users are going to be that need to access the information.
Brett, that's a great job in summary. Bill, is there anything just quickly that you want to add, or just an example you want to pull out?
Sure. Just to say briefly, when you talk about cloud systems, this migrates a lot of issues that we're not exposing internal laboratory systems to customers. We're presenting the data. Data has been published into a cloud environment, and we're not reliant on our internal networking folks and IT staff to, provide what can be very advanced data encryption, etc. Our system, for example, we encrypt all at-rest data. So a lot of advantages, again, to cloud services.
That's fantastic. And again, we'll try to keep just a minute or two on some of the results. What are some of the tangible ways that we've seen the impact of some of these systems for laboratories?
Yeah, I'll touch on this. I think we talked a lot about it already, but let me just recap it a bit. So self-service, reduce customer service staff, stop mailing out those paper reports, save time and material on that. Potentially introduce online purchasing, allow the customer to buy stuff from you. Analysis of usage, be able to have a feedback loop and how you're presenting data and improve upon your presentation. Get the data in the hands of your customer much faster, make them happier, grow your business. potential to allow customers to repeat orders without company interaction. Competitive advantage, it's a big one. Improved turnaround time, accuracy, what you can charge per test. So maybe if you automate a lot of these processes and there's a lot less involved as far as time and money to get the data out, you can potentially reduce your costs and become a good competitor in your industry. One of the example we have as far as portals and what it can do for a company is we put one in place for a company, and they stated that's one of the top 3 selling points when they go out to make sales, is that they have a nice presentation of data that's available on demand and configurable as they need to look at it.
Brett, that's phenomenal. I don't think you touched on so many good things. I think you had about 12 great impacts. Probably all those things we could go into extreme detail on how it saves both time and money, and is also a better customer experience. So again, maybe that'll be a future session that will cover each one of those in detail. So again, just in summary, here's some things that we talked through today about lab-specific customer portals, positioning you as relevant, helpful, and friendly. Again, helping your customers get that data fast, easy to understand. Tailoring the reporting needs for your customers. Again, the benefits of self-service there. Offering high levels of accessibility and security is a must. And again, the ability to earn some substantial ROI through, again, cutting some of those time-consuming tasks, and also things that are costing you money right now that we can make more efficient. That concludes. Do we have any questions today we can try to answer? Let me take a look. We do have one question that came in here, which has to do about the customer portal specifically. It said, how do you normally manage adding or removing permissions for a user?
Oh, I'll take that one, Mark.
Sure.
So and I'll just be very brief here. And we talked about managing our data from a perspective of laboratory data or equipment information. That extends into the user management. So user permissions and user roles and who gets to do what on the site. And that is all needs to be something that can be managed within the portal itself. And that's a great strength, because you're able to get that customer facing. So if they have a new staff member, they shouldn't have to call your support or your salespeople just so they can have a new person added to their account.
Bill, I think you're exactly right. I hope that answered the question well. Yeah, definitely managing those permissions, managing the portal itself is a key factor that can really streamline things for customers. So thanks for touching on that. All right, well, that wraps us up. Thank you all so much for attending. It's been a pleasure going through these several sessions with you, again, about properly gathering, analyzing, and presenting test data. We hope you found some of this content extremely valuable, and we just want to say that we're here to be a resource for you if you have any questions, as we strive to make especially testing data, complex testing data, simple to understand for both you and your customers. So thank you so much again for joining us, and we will hopefully see you again soon.